Good evening, everyone. I apologize for this 5 minutes delayed start. Before I start talking about my experience of designing systems which uses or leverages blockchain at some level, I wanted to ask a few questions just to get an understanding of where you guys are in terms of what level of expertise you have in blockchain in general. So how many of you understand the difference between cryptocurrency and blockchain? Is that clear to everybody? Cool. Because the last time when I was giving a similar presentation, one of the feedback that I received was it would have been great if I would have told a little bit about blockchain versus cryptocurrency. So I wanted to make sure that I get that out of the door first. How many of you know what is a smart contract? Okay, pretty much everyone. How many of you understand the difference between miner, who does the mining, different nodes that you have in blockchain that are responsible for signing transactions, like these different terms, basically. Okay, cool. So if anyone feels that I'm going too fast on this presentation or I am using terms that they are not familiar with, please raise your hand and feel free to ask me what am I talking about in the first place. So this presentation is more about just me sharing my experience of designing different systems where we ended up leveraging blockchain. Now, when I usually think about an architecture, I usually would think about it as a infrastructure layer, as a processing layer, and then you have your main application layer. Now, blockchain has its usage at the infrastructure level, which means where you actually use it maybe as a database, just to store information, or maybe as a processing engine where you have smart contracts. You could also use blockchain at your middleman layer, which is where you have your business logic built in, and you do some processing as well. And then you have your application layer, which is where most of your dApps would go to. So this presentation is about just taking through different use cases that we came across in last 1 year, the projects that we did, the POCs that we did, the challenges that we had in last 1.5 years pretty much, and how did we actually ended up making decisions and what were the considerations that we actually had to go through while taking those decisions. There were always pros, there were always cons. They were not the best decision based on the maturity of the technology at the time, but it did work out in the end, and if nothing, then we had few lessons that we learned on the way, which I wanted to share in this presentation. I don't know what's happening today. So I can load my first slide, but the second slide is not loading at all. No. I can actually do it, but so while it's loading, I just wanted to give a brief overview of who I am. So I represent here an agency called Systango and Studio Fintech. Studio Fintech is the financial arm of Systango, focusing on fintech startups, fintech companies, anything to do with the blockchain. Before I started Studio Fintech and I started Systango, which is about 175 people company in London. Before I started this, I was working with Goldman Sachs for about 6 years. Majority of my career I've spent in front office, dealing with trading systems in different security classes. So I've worked in fixed income, I've worked in little bit in currency as well, commodities as well. But most of my background and my business knowledge is restricted to financial domain, is what I would say, based on my career history with Goldman. And then within Sistango, we worked in different sectors. Like we have done some work in hospitality, we have done some work in telecommunications, but then again, majority of the work is fintech and blockchain. Oh, there you go. Cool, now it's working. So this is technology. Just to clarify, everyone, what is a blockchain? So when I heard about blockchain like 4 years ago, I think this was 2014, 2015, I was like, it's just a linked list. This is the same data structure that I have been studying for like last, 15 years. What is so special about it? Why people, why there's such a buzz, why there's such a hype? And if you think about it, blockchain is a linked list, except few more characteristics along with it. It's a linked list that's generally immutable. It's a linked list. When it accepts a transaction, it has a process, it has a protocol before a transaction gets accepted in that linked list. And I think those are the characteristics that actually makes blockchain unique and special. What are the different types of blockchains? Is everybody familiar here with public blockchains, with private blockchains, with consortium-based blockchains or federated blockchains? Yeah, cool. And I'm pretty sure, in last 2-3 years, everyone have heard of the potential use cases of blockchain, be it financial industry, be it gaming industry, be it government sector, public sector. There are immense use cases that everybody has talked about where blockchain can be super useful, or blockchain will bring the needed transparency, it can change the world. So I know that people have been saying that the way internet has changed, the world, this is like the next phenomenon in technology. However, okay, cool, again. Okay, so however, I think what demands this conversation is when you design systems for enterprises, it's hugely different from the systems that you design for startups. Your requirements vary. Your requirements are around throughput. Your requirements are around resilience. Your requirements are around performance, privacy. So when you are, say for example, one of the systems that we did, we were tasked by a company that works in healthcare sector. They wanted to deploy the solution in an African country, and their use case was that they wanted to store the medical history of every single citizen that they have in the country on blockchain, and access to those records should be controlled or governed by their biometric recognition match, by their facial expression match, and the complete medical system will run off that whole architecture. Now, if you think about that use case, what we needed to do was store every single medical record to begin with on blockchain, control the access, and then if the access is granted, then make alterations or make amendments or make incremental changes to that record that is in blockchain. In a country which has millions of people, even if you do the calculation in terms of, let's say, in a day, 0.01% or even less than that actually accesses blockchain or accesses their medical records, then that actually came down to about 40 transactions per second. So at any point of time, there will be 40 to 50 requests per second that this architecture needed to process just in POC, even if you don't actually open this infrastructure to everybody. So we were talking about onboarding 10 million citizens to begin with, storing their records, and then controlling their access via a biometric recognition application, and then doing all of this pseudo real time. Now, when we started thinking about it, and then we started thinking about which blockchain can we actually start storing records into. At the time, and this was back in, I would say, April of this year, 2018, we did not had a lot of choices in terms of mature solutions out there. We looked at Lisk, we looked at Ethereum, because everybody wanted to give it a try. But it was a no-brainer that ultimately it all came down to Hyperledger. Now, Hyperledger is a private blockchain. However, the way we ended up configuring, we actually ended up passing through 40 to 50 transactions per second. And with the nodes and with the architecture that we were able to set up, we were actually able to make that thing work. And it's deployed right now. And it is scaling. So we're going to go through the architecture of that application in next slides, but that's one of the use case that we encountered. Similarly, there's this one company that we are working with right now. They want to have a wallet which has similar characteristics to cold storage wallets, but they want their customers to be able to execute their trades real time, even while storing their assets and securities on this HD wallet. Now, this specific solution doesn't really require blockchain, but it ended up talking to different blockchains because an individual customer could have Ether in their wallet, they could have Bitcoins in their wallet, it could have different cryptocurrency in their wallets. So that's another architecture that we're going to go through. We also ended up working with a company that's based in London, where we ended up storing all the company records on the blockchain, and then the whole notarization process uses and leverages the records that get stored on the blockchain. So we're going to go through those architectures later in this presentation. But the thing that I wanted to point out was these were the different use cases where you cannot just go and select let's just use this blockchain and let's see how it performs. Irrespective of what I like as a programmer, I had to make more pragmatic choices of is this technology mature? What is the community support out there? If I end up in a problem, then who can I reach out to solve that problem, basically? So let's go through different. Actually, one more good point. So while we were working on these different use cases, one of the key questions that we always ended up asking ourselves as well as our customers. It's not the case right now, but at least a year ago, everybody wanted to use blockchain in their architecture. Be for the reasons of investors asking them, stakeholders asking them. For one or the other reason, people just wanted to use blockchain. We want to have a solution that uses blockchain. And what we ended up in the end saying to everybody who we worked with was use blockchain for the purpose of blockchain. If it serves you a meaning within your architecture, only then use it. Otherwise, there's no point in just adding a layer which is not even matured at the time, and adding a lot of bottlenecks to the complete system just for the sake of using a technology which you want to use. Now, how do you actually decide what blockchain to use and if you should actually be using a blockchain? The different factors that we went through were, first and foremost, who needs access to this data? So in different use cases, for example, this African country medical records validator architecture, the only people who needed access to this data was government entities and the entities who are going to sign, the transaction before it actually gets stored. So there was no point of even considering a public blockchain over there. Second that we were going through was scalability. So what is the performance and throughput requirements? People keep talking about running their financial transaction through blockchain. People keep saying that one day we will have online payment system and we will potentially be able to run all the credit card transactions through blockchain. Visa processes like 1.5 million transaction per minute. If you put blockchain in that architecture, there's no way blockchain in the current shape can actually replace that. Be it Bitcoin, be it Ether, there's absolutely no way those scalability requirements or those throughput requirements can be met. So similarly, for our use case, for the medical one, where we did not really wanted 1,000 transactions per second, but we were still needing 50 to 60 transactions per second to avoid bottleneck in the medical recognition system. So for us, at least there, performance was main concern. Immutability and data integrity. I'm pretty sure, everyone over here understands that blockchain by its nature is immutable. That is what it differentiates us, distinguishes it. In our systems, I think that was one of the criteria that we needed in the system to serve, that we needed our data layer to be immutable. Now, while we were doing all these systems, we also looked at the enterprise version of Ethereum. However, again, this was the system that we were developing 8 months ago, 7 months ago, and that was not ready at the time. Anyone has any questions? Yeah? Uh-huh.
How about in segmenting the payments, by amount from 0 to 10 is dedicated to such one type of blockchain, from 10 to 100 another type, and so on. Is this a potential solution for this company? Instead of one blockchain for every payment in the world, we can have several blockchain networks for
But how would that solve the problem? Theoretically, that can solve the problem by making an assumption that, say, the number of transactions that going to happen between 0 to 10 euros going to be less than 10 to 20, or you do a compartmentalization of transaction and you are then doing it in parallel, right? But the challenge is still going to remain the same, that the number of transactions that you can do per second is hugely different from what you need versus what any of the blockchain right now can offer. So there are initiatives that are going on right now to support. Like, for example, I think there is Lightning framework, which is, I don't think it's launched yet, but that would probably enable micropayments on Bitcoin blockchain, right? But I don't think right now, at least in my knowledge, I've come across any of the blockchain that even if you compartmentalize the number of transactions, can still serve the number of transactions that you need at any point of time. Yeah? Any other questions? Yeah?
How big is the file size for such a transaction of medical records? How big is the data we are talking about?
So we ended up doing storage on-chain as well as off-chain in this architecture. When we looked at all the medical records, the average size was anywhere between 5 MB to 10 MB. And that's where we ended up going on-chain and off-chain. So not everything was stored on-chain. Anyone else? Okay, so this is a general, a very generalized sequence diagram you could say, for the medical record collector and validator flow. Again, there was not just one server, there were many servers. There was queue as well in between, which was prioritizing read request over write request. So we had queue between server and blockchain. And then on the client, we had a browser app and a mobile app, so that a user goes in, they put their face before the app, the recognition happens. If the record matches, the identity matches, then the access is granted. So that work is done between client and server. So as you can see, the first one server has done the handshaking with blockchain. The registration request comes from client to the server. Server then makes the request to the blockchain to store the identity. Any validation request that comes in comes from client, goes to the server. Server retrieves the record from blockchain, and we had the cache as well on the server. So we had the cache, we had the queue, and then if the validation is successful, then the identity token is returned to the client. After that, the access to the medical records has been granted, and then any updates sent by client to the server goes on the blockchain. So this was like the typical flow or the use case of the medical record collector. Similarly, we also, so the reason why I want to go through this as well, along with the medical record collector, because there is a lot of commonality between both the use cases, even though they are two very different use cases. So this is the solution that we did to roll out a digital currency. Now, I don't know about Germany, but in UK we have, say, Oyster card, right? So it's a card that you can use to commute on the trains. And you actually, the currency that is used over there is pound, but ultimately it's a digital currency that goes on your Oyster, and then it gets deducted from your Oyster. And that's how you get Oyster points as well. Now, if you were to do a similar currency rollout on blockchain, this again is the solution that we did for one of the African nation. The flow was, there is a server, there is a client, and you'll see a commonality between all the blockchain applications, at least in my experience, all systems that we have designed always had a server in between. We could never have our business layer talking directly to blockchain unless it was a straight vanilla smart contract that we could deploy on, say, Ethereum and have an app directly talking to that smart contract. We always had a server in between that could do a lot of caching for us, that could even talk to a relational database for us, and then talk to blockchain for us. So even over here, we had a server. The digital currency, by the nature of the currency itself, it did not need it to be modeled as a smart contract. It was, if you ask me, could you have used, instead of a private blockchain, a relational database? I think yes. The only additional advantage that we got or we obtained by using a blockchain is the trust factor, is the immutability factor. So that if somebody comes and reviews the architecture, and going forward, let's say if there is a financial consortium of 3 or 4 banks, you could give them each a node and you could give them a power to sign the transaction before it gets stored on the blockchain. So just to take you through this, there is a client. Let's say I, as a consumer, walk in, I subscribe. The subscription request, the registration request goes on the server. Server stores the user details, whatever the balance of the user, etc. is, on the blockchain. And then any transaction that happens on the client app goes on the server and then gets stored on the blockchain. This application also lets users to talk to Ether blockchain, Bitcoin blockchain, and I think we also integrated with Ripple in this case, so that we could get users XRP balance as well, and that is where you would see different blockchain blockchain nodes in here, and the server also subscribe to individual blockchains. Sorry. Is everyone okay so far on these two diagrams? So this is just like, let's say if there is a credit or debit. So on these type of solutions, we also had to go through use cases where people could use other wallets, they could use other applications, and they could actually make changes to their balances that get stored on, say, Ether blockchain, or let's say on their Bitcoin blockchain. So we also wanted to make sure that we get an event whenever there is an update directly happening on those individual blockchains within our infrastructure as well. And so the way we did that was we had different nodes running for us. So we had an Ether node. We also looked at Infura. How many of you know about Infura? Few. So Infura is basically, I would say, a node that you can go and subscribe to. You pay for the subscription, and you can basically talk to that node to talk to the Ethereum blockchain in a very generalized manner. But we ended up running our own Ether node. We ended up running our own Bitcoin node, and then we subscribed to those nodes to get any transaction updates on the addresses that our consumers, provided us. The third use case is the company house data collector. So again, this is very similar to the medical records. We stored every single company director information on blockchain. Again, part of the solution was on-chain and off-chain. Is everybody clear when I say what's on-chain and what's off-chain? No. Okay. So for people who don't know, on-chain is, so if you have, let's say, 10 megabytes or 50 megabytes of information that you want to store, sometimes just storing everything on-chain, which is like on your main blockchain, can be very inefficient, because then you have to make a read call to read complete information from your blockchain, basically. So what people ended up doing in last couple of years is that you would generally store the bit that is most important for you and that is good enough for you to be able to recognize the sanity of your complete data set on the blockchain, and then you store remaining information elsewhere. And that elsewhere can be your secondary blockchain if you want, or it could be just your relational database. And there are various on-chain and off-chain solutions out there that you can also use. We also used, how many of you know about big chain database? So yeah, there are quite a few. So we use big chain database a lot as well in our architecture. In POCs, I mean, we haven't used big chain database, I think, in any of the enterprise implementations that we have done. In all the enterprise implementations that I'm talking about, most of the private blockchain ended up being Hyperledger. For its, I think more than anything else, it was more because of its support. So if you have any problem, you can reach out to Hyperledger Fabric guys. And the big advantage with us was the team sits like 2 floors above our office. So we could just walk and go to them and ask them. So it was as easy for us to get those answers resolved. Otherwise, we ended up waiting for days just to get a response on a question that we are stuck with, and then you just can't do anything. So I think our choice of Hyperledger was more driven by the support guys offered, and I think to some extent the scalability that it offered for the use cases that we needed to serve. How many of you have developed a system that actually uses blockchain? There are quite a few. So have you ever come across a blockchain that serves your performance requirements, that serves your immutability requirements, and that serves your resilience requirement? Sorry, say that again. Were you? And which blockchain did you ended up using in that architecture? Oh, okay. All right. Okay. Anyone else? So from the research, and this could be maybe outdated for like today. I think if I were to start a system, like designing a system today, probably my choices will be different. But all the systems that we developed, we started designing them, say, 8 months ago, 9 months ago, 10 months ago. And the only conclusion that I always ended up making was that it's just not possible to have one blockchain that suffices all your needs. Like, if you want to make it transparent, if you want to have immutability in it, and then at the same time you want to have your throughput requirements, your performance requirements, public blockchain, like, we just couldn't go anywhere near it. As I was saying earlier, Hyperledger was the one that we ended up using. We tried using Lisk a lot. How many of you have used Lisk? No? So the reason why I personally liked Lisk was because of its throughput and because of because you could code in it in JavaScript. Like, for every other blockchain, for Hyperledger we ended up using Go. But for every other blockchain, you needed to pretty much like learn something new. Either it was C and C++, which I'm just not very familiar with. But Lisk was the one where I could just start straight off. Even our team could just start straight off. But with Lisk, we had challenges around scalability. So its throughput was good. Immutability was definitely there, but it was just on. Actually, the resilience was a problem as well in Lisk. So anyways, coming back to this, I think in my experience, there was no one blockchain that could serve everything. We always ended up using hybrid solution, on-chain, off-chain, multiple blockchains for doing different things. As I'm pretty much sure, like everyone's aware of it here, private blockchain. Some people like in the debates always tells me that if you were to use a private blockchain, like what's the point of using a blockchain in the first place? I think from my perspective, it's a start to different big consortium giving you access to immutability and transparency. At some point, if there is an audit and if somebody goes in and starts reviewing those transactions, you at least have that surety from regulation point of view that nobody can actually tamper with those records once they are in there. Because if you have inserted something, you cannot change it. You can only incrementally put another transactions over it, but you cannot go and alter the existing transaction which is in blockchain. How many of you have used blockchain as a database? No one? Yeah. So that's my biggest advice. Never use blockchain as a database, and it will never scale. If you just use it for storage perspective, even if it's offering you immutability. One experience, as I was saying with Hyperledger, was because blockchain is such an evolving infrastructure, and because the technology is, even to date, is in its infancy stage. In our experience, it always paid off when we went ahead with with a solution that had a lot of community aspect around it. We always tried making sure that whatever solution we end up using, we do a lot of POCs with it. We do a lot of like due diligence around it, around our requirements versus what that technology is able to offer in the first place. So this is just about Sustango and Studio FinTech that I partially covered in the very beginning. So we are a consultancy that that basically digitalizes or put your solution on, like, blockchain. That's what we specialize in. That's it. If you want to have a in-depth conversation around the architecture, around, like, different bits that we ended up using, then please do reach out to me. I'll be more than happy to, like, share those architecture diagrams. Yeah? Any questions? No? Thank you.